Howdy. Greetings from southern Oklahoma, and we are going to attempt to explain a Markov chain. Now, well, perhaps not the official definition. If you want the official definition of a Markov chain, spelled like this, I think Markov chain, something like that. Anyway, if you want the official definition, you can go to Wikipedia or something like that. But really, I'm going to sort of explain how you can chain words together and how you can use statistics for a variety of reasons within using these words and word chains. Also, I'd like to attempt to explain perhaps how you can use some of this information with regards to an AI development, especially when you have a user sentence and a response situation where perhaps you can sort of use this Markov theory to gain a certain type of way of learning and a certain type of AI learning and a certain type of response that you can get from your chatbot. So anyway, first things first. There are examples of types of Markov chains, especially in general use. If you think of a cell phone and you go to text a message, or perhaps there's other programs that's like this, not just cell phones, but you go to text a message to somebody and you go to type in a word, and the program not only guesses, some programs will guess what type of word you're actually trying to type to aid in spelling, but I've seen them where they've also predicted what word will probably come next. I know that there's more programs that do this besides text messages. Not everybody's text message program does that, but I think OpenOffice and LibreOffice and programs like that actually sort of guess perhaps what you're going to say next sometimes. It just depends on the program. But what happens is as you use your product, as you use your phone, and perhaps you've given many text before, and say you say one word like hello, and then say you greet Bob, a fellow named Bob, all the time. You say hello, Bob. And every time you write a text message, you say hello, Bob, over and over and over again. Well, your phone learns that, or a program can learn that every time you say hello, most likely the word Bob will follow. So statistically, Bob will always follow hello because you taught your phone that. And so next time you say hello, it will give a guess of Bob as being the next word, and will sort of perhaps give a faint ghost of the word. Sort of, it's like asking you, saying, is this the word you're going to say next? Like I said, not all programs do that. I've had phones do that. Maybe yours doesn't, but I think it's pretty neat. It aids in typing, of course. It aids in any type of program that you use often, like text messaging. But it can also be used in AI, artificial intelligence. Now, there are different ways of creating this statistics, because there are precise ways and imprecise ways. And the first thing we're going to do, we're just going to jump right into the basic principles of this Markov chain idea. And we're going to start off with a 1-to-1 ratio. In a 1-to-1 ratio, you have that's when you, like, every time you say a word, like what I used a while ago, the example, hello, Bob. Say you say this phrase right here. A 1-to-1 ratio is that every time you say hello, Bob should follow. A 2-to-1 ratio would be like, if you said hello, Bob, Smith. Okay, so perhaps his name is Bob Smith. I'm sort of making this up as I go along, the examples here. So every time you say hello, then, excuse me, that's a 2 to 2. There we go. A little mistake there. Okay, anyway, every time you say hello, Bob, then it guesses that Smith should follow. So it's more precise. It's like if you said hello, it won't just guess Bob Smith that's going to be next. It would only guess Smith if you say hello, Bob, then it guesses Smith. So it's like a more precise thing. You have to have more words here in order to guess the next word. So it's more precise. Say, like a 3 to 1, 4 to 1, 5 to 1, where you have to have a whole sentence before it guesses the next word. So it's a sort of a precise ratio. Now, the opposite is true too. And I almost did that. Well, the opposite of this is something that's less precise than a 1-to-1 relation. See, a 2 to 1 is more precise than a 1 to 1, and a 1 to 2 is less precise than a 1-to-1 ratio. So in a 1 to 2 ratio, this is sort of get your feet wet into what we're doing here. It would be something like this. Say you said the word hello, and then your program just automatically guessed Bob Smith. Okay, that's 2 to 1. So it's like, sometimes you may say hello to Bob. Sometimes you may say hello to Jane. Sometimes you may say hello to Ted, just anybody. So it's like 1 to 1 is not too precise, but it's more precise than saying, if like you said hello and then it said Bob Smith, or perhaps a 1 to 3 ratio where it says hello. When you say hello to the program, and it says Bob Smith was. It starts to write an entire sentence, you see. Like a 1 to 15 ratio is really imprecise, where you say hello, my name is Bob Smith and I'm here at the house waiting for your text. Why haven't you texted me? So just imagine a text message program, guessing an entire text. Said, oh, you want to say this text? It's like really imprecise. So you want to be precise, but you don't want to be too precise. If you're too precise, it will never be able to guess what you're going to say next. Like if you had a 15 to 1 ratio where you had to write an entire huge sentence in order for it to guess the next word. You don't want that because that's too precise. And you don't want something so imprecise that it writes an entire conversation when you said the first word. That doesn't make any sense. So this is just give you an idea, a taste of what a ratio is in regards to chaining words. And surely you've already caught on to what chaining word means by now. It's where you say a sentence and where one word always follows the other, or most likely follows the other. I'll get into that next here. So it said, what does it mean like your rating, where something comes after something more frequently than not? Well, we can write a table here. I'll use some of this screen. I don't know. Well, try to make it a little bit straighter than that. Anyway, I'm sure there's a way of doing this with this program, making straight lines. We'll try to make a table here. Okay, in this table we will have 3 columns. In the first column, there's going to be a word. Like, use our example again of hello, Bob. So the word right here is hello. Now, we'll use this table a few more times. So we're just going to give these columns a label here. We call this the lookup column because we're going to be looking words or phrases or sentences up in this first column. The second column, we're just going to call the follower. I just put follow. And then the third column, sorry about that little cross thing. And the third column will, the rating column. So we're going to rate certain words. Now, say the word we said hello Bob, a while ago, using this example, this silly example, hello Bob. Say you say this a lot of times, okay? Well, the first time you say hello Bob in your little text message program, it saves the word hello. And remember, this is, in this case, it's a 1-to-1 ratio. So we say the word hello, and the word that follows is Bob. Okay, we said it one time, right? The first time we ever used a phone, first time we used this text message program. So we said it the first time, hello Bob, and perhaps Bob responded, who knows, but we said hello. Let's say Bob didn't respond, because, we might have to say it a few more times. And so the rating of this would be 1. Because we said hello Bob, and we used the Bob right there the first time. This is the first time it's been used. Okay. Now, let's say he didn't respond, so we wrote this again. We said, hello, Bob. It's like, why aren't you answering? Hello, Bob. And so we did it again. So now the rating is twice. 2. We said Bob twice. When we said hello, we said Bob. And this Bob right here was said twice. Okay. So the rating of Bob in this case is 2. Okay, now we're getting a little worried, said, is Bob dead or something? And we say, hello, Bob, and we use an exclamation point, we really just emphasize it, but we said, hello, Bob, and so we did it a third time. Okay, now the rating is 3. Okay, and so, so he finally answers or whatever, and okay, so the day passes, and we decided to text somebody else. We say, and this time we say, hello, Jane. Hello, Jane. Okay, so we say, hello, Jane. And so we have this lookup word again, hello. Right here's the lookup word, the first word here, hello. So this is a 1-to-1 ratio, it's 1-to-1. Okay, so we have the lookup word, hello. And now we have a different follow word called Jane. Hello, Jane. Okay. So we use this. This is the first time we said hello, Jane on this phone. So what's the rating? The rating is 1. Now, perhaps we said hello, Bill. Bill's a friend of Bob. Yeah, they've known each other for a long time. So again, we do the same thing. The lookup word is hello, the first word there. And so we say Bill. And it's the first time we've ever used this phone. So first time we ever texted Bill, he has 1 rating. Now think about this for a minute. Next time we get a hold of our phone, we open up the program on the text message, and we write the word hello. Which of the following words of Smith, Jane, or Bill will your phone guess as being most likely being the word that follows hello? What's statistically most likely that I'm probably going to say next? Well, the phone is going to guess, and it's going to be Bob. Why? Obviously, because Bob was said 3 times in the past, but Jane was only said once, and Bill was only said once. When you said hello, statistically, Bob, right here, statistically, Bob is 3 times more likely to come after hello than Jane or Bill. And so it's a 1-to-1 ratio right here. Now we can increase this ratio too. Like we said, hello, Bill. You sort of should get the idea at this point, but we'll just go ahead and add another layer, some more depth to this. Jane um, uh, Christian. I have to use a long name. Bill Snow. Use my last name. Okay, so we have Bob Smith, Jane Christian, and Bill Snow. Okay, we have this 1-to-2 ratio here. Let's just say we have a 1-to-2 ratio. Well, every time you say the word Bill or hello, we'll have Jane Christian. Or we have Bob Smith, or we have Bill Snow. I don't have much room here, so I'm just sort of shortening it. And so every time you said hello, it would guess the entire name, Bob Smith. So, like we said a while ago, or earlier on, that this is less precise, but you see this 1-to-2 ratio. Same thing with a 2-to-1 ratio. Let's go to a 2-to-1 ratio. 2-to-1 ratio. So the first thing entry in the lookup column wouldn't be hello anymore. It would be hello. Say in this case would be like a hello Bob. Okay, and perhaps for this to work, be like hello Bob. The next time you see this one, you said hello Bob Smith. Just hang on a minute. We got to correct this stuff here. Yeah. Okay. You said hello Bob. Hello Bob Smith. Hello Bob Snow. You know, you get the hint. Hello Bob. I don't know. Of all the people I know, you'd think I'd just come up with a last name. I don't know. Hensley. Whatever. Okay. So you said hello Bob the first time, and it was Smith followed. Okay. Same thing again. You said hello Bob Snow. So Snow followed the second one. And the third one, Hensley. So what if you said hello Smith 7 times? Well, you'd hello Bob Smith 7 times. Well, it would register rating as 7. You only said hello Bob Snow 3 times. It would be rating as a 3. Hello Bob Hensley, you said twice. And so next time you get on your program with a 2-to-1 ratio, next time you said hello Bob, it's most likely going to follow with a Smith, because statistically that rating is higher. Yeah, I think this is all cool and neat, you know, but I have fun with this. I hope you enjoy this too, this type of thing. Now, if we're going to say, you can actually enter entire sentences into a database and actually learn their statistical values, because you can sit there and chain an entire sentence together in this way. Like, a cat smells bad. I should like write, my writing is very terrible, but you know. A cat smells bad. Okay. We're going to put this sentence into a table using a 1-to-1 ratio. Well, more likely several tables, as you will find out. So how would we do this? And then we figure out how would we retrieve this data. Okay. So a cat smells bad. So the first thing we do, we have this table. We have the lookup, this is probably for reference here. We have the lookup, the follower, and then the rating. LFR. Okay, a little bitty, like a small table. The first column would be, first word would be A. This is the lookup word. The following word would be cat. And since we only have one in there, the rating would be 1. Then we move on down the sentence. What's the next word in the sentence? Because we're on a 1-to-1, so we jump to the next word, cat. So we'll make another table with 3 columns. We don't have to label the columns this time. First one is the lookup word is cat, and the word that follows is smells, and the rating is 1. See if we can't speed this up a little bit. Yeah, we're at 21 minutes. Okay. Next word is, the lookup word is smells. Following word is bad. And that's the end of the sentence right there. And there's a rating 1. So a cat smells bad. We have 3 tables here. Okay. Now, what happens if we put this into our program and it looked up the entire thing? It's in a 1-to-1 ratio. A cat smells bad. Next time we say a cat eats food. Very simple, okay? Cat eats food. So we go to our lookup column again. So A is already there. Cat follows it. And this time it follows it twice because we just got through saying it twice. Cat eats. Okay, this differs. Though we have the same lookup word, cat, the word that follows is eats. And we only said this one time. This is the first time we said this. Now, finally, then, of course, food. Now, what do we do here? Well, we have to make an entirely new table called food with a lookup word of food. Let's see. Wait a second. Oh, eats. Excuse me. Sorry about that. Because remember, we just moved over one word. In this case, it's eats. Look at the word called eats. And the word that follows is food. And it's the end of the sentence. And the rating is 1. So we have 2 different sentences entered into our database, and they both have a statistical rating. Now, the next time I say enter into the program a cat in a 1-to-1 ratio, of course, it's going to look up the word cat. Okay, I type in the word cat. What's most likely here? Well, in this case, I see it's equal. So we can actually pick a random value in this case when you have 2 ratings that are the same, or you can use some other algorithm just to guess something here, you know. And so in this case, it would be something like that. So just you could pick either one, smells, and then over here smells bad. So since there's only one option here, we only have one choice. And so we could, like, statistically, we say a cat, we can guess on the smells, and then smells will always be followed by bad. Now, what if we, it's like if you sent 100 sentences like this, and you keep adding this information over time into your text message program, and you keep adding different sentences, different types of sentences, it will create more and more and more and more and more of these tables and create systems of ratings. Say, for instance, if this was a 2-to-1 ratio, it would say smell, because smells would have a higher ratio. When it went a cat and it says look up the word cat here, well, most likely the ratio would most likely you would say the word smells after cat because you said smells more often in your sentence. And so you can sit there and guess an entire sentence like this, where it goes to a ratio. Well, this is 2 ratio. This is 1. This is this word right here only follows this word because there's no more options in this table. Or if it's same thing here, if it said the rating was 2 on eats and it was 1 on smells, it would go all the way over here. I mean, you would put down eats here, and then what follows eats? Well, food always follows eats because we have no more information in this table. And then I always like to say I always like to give sort of indication, perhaps adding a mark, especially when you're adding this to a database, that typically this is the end of a sentence. So you don't create an abnormally long sentence like this. You probably want to create the shortest sentences that you possibly can. So it's good to indicate when typically you've hit the end point of a sentence that you have entered into your database. I hope you sort of understand that. If you go to try to program this, you should be able to sort of grasp this. Say I enter in like 1,000 sentences, and perhaps some sentences are longer than others, and perhaps some words extend out further than others. Well, you can have some pretty weird sentences when you statistically build a sentence, because you can statistically build sentences in this form. But, like I said, I just give you that food for thought. I don't mean to confuse anybody. It's sort of, there's a lot of things you can do here. Now, remember, this is just a 1-to-1 ratio. So we can, it's like moving on, This is a 1-to-1 ratio, but we can go to a 1-to-2 ratio, a 1-to-5 ratio. We can make this less precise. Sorry about that. That's less precise. We can go to 2-to-1 ratio, make it more precise, where it says, excuse me, this is a big mess here. 2-to-1 ratio. So it could be a cat would be the lookup word, and what follows smells. It's 2-to-1. Then the next word we come across is we wouldn't say we would just move 1 over in the sentence because it's the next twin. It's the next 2. Not like skipping over. Like the first time we would say a cat would be the first thing, the lookup, and then we'd say what would follow smells. And then the next one, the next table, the lookup would be cat smells, and then would be followed by bad, the follow word, for a 2-to-1 ratio. So you always move over 1 in the sentence when you're adding these tables. That's a typical thing. It's good practice. I'm sure there's probably different ways of doing this, though. Anyway, you can actually use this as a sentence builder, like statistically. If someone says this word, what sentence most likely will be built around that word? Statistically. So you can actually create a sentence builder with this. But we're going to go a little bit further than that. There's another way of using this, not just with words. We're going to briefly talk about sentences. We're at the 28-minute mark. So I'm just going to briefly go over this right here pertaining to sentences. Now, let's say we have this artificial intelligence, and we're trying to teach this artificial intelligence, if I say this thing, then you say that. That's usually how artificial intelligence program or chatbot usually works. Doesn't have to, but this is one of the simplest way a chatbot can work. Like if you go ahead and pre-program a chatbot to say, if the user, excuse me, I can do a better job than that. If the user says hello, then the AI should say hi. And you can sit there and tell it to do this. So every time I say hello, then the AI will respond with hi. That's the most simple detect and response technique. But you can teach an AI using sort of a MarkOv-like thing, a MarkOv-like idea. Now, when I say an idea, it's not exactly precisely necessarily. You don't have to make it precisely with the Markov chain theory when you're dealing with conversations, but you can use the 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 main concept of the cool thing about a Markov chain is the rating. It's like this response is more likely than some other response, and you can use that in an AI. Now, let's say that we have 10,000 sentences, and they're all conversations, and we don't know who said what to who, but we do know that there was two people involved, and it's like you had this giant archive of conversations where um, person A said this, blah 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 blah. Person B said this in response, blah 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 blah. Person C, or excuse me, person A again responds to what person B said, blah 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 blah, and then person again, same thing here. Person B responds to what A just got through saying. So they're all linked together in a chain, a long conversation. And perhaps we don't know who these two people are, and perhaps it's a generic conversation. And there is a way of teaching your AI possible conversations just using the Markov chain idea. And that's what I'm fixing to sort of tell you about right here. Now, say we have this giant list of these type of conversations, blah 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 and blah blah blah, and it goes on and on and on and on. So it's like just playing conversational tag. One says one thing, the other responds, and vice versa. Keeps going on and on and on and on forever, or however long. Maybe it's 10,000 sentences long. Okay, how do we put this within a Markov chain idea? Okay, remember our table. Okay, so we have this table, and okay, like before, we have the lookup, we have the follower, and then we have the rating. It looks like a V, but I don't intend it to be a V. Okay, so the first sentence, we can have in this case, call it a 1-to-1 ratio. This, instead of being words, we make it entire sentences. 1-to-1. So every time we say the first sentence, we have this first sentence here. Person A said this first sentence. Well, okay, this is the first sentence. Blah, 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 blah. Okay, person B responded. So this is a 1-to-1 ratio. This is the response. Blah, 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 blah. The following sentence. Look up, follow. And then this ratio only happened one time. So every time this person said this word right here, this sentence right here followed. So we have a rating of 1. Okay. That's person A, blah, blah, and person B, blah, blah. Okay. Now, again, we move to the next one. Person B, the person A. Person B said that'd be like a whole other table. So let's go ahead and say we just made another table. I don't want to do this again. So we created this table 2, this table 2 now. Okay. And so in this table 2, we have B is the lookup because we just moved 1 down. B is the lookup, and then A is the following sentence. And then we add a rating. Now, say we keep going down this list of conversations, and say, for instance, now the lookup, say B, we made all these tables, perhaps 50 sentences in there. Then all of a sudden we had something that had two, perhaps person B said the same thing twice in this conversation. Perhaps early on he said, "Hello, Ted." And of course, person A responded with whatever person A would want to respond. So let's say later on, person B said, "Hello, Ted," again. Well, we've already created that table that said hello Ted. That was the entire sentence, hello Ted. So we had to, since we have a duplicate, so what follow, then we'll find out what was following. What word followed, what response did person A say to hello Ted? Perhaps person A said the same thing twice. Well, if person A said the same thing twice in regards to what B had said, then we would go ahead and add another rating to whatever B or whatever A had responded. So what if A said something different than what it said before? When the last time Bill said hello Ted, well, now person A is saying, oh, I thought you already said that. Or, yeah, I remember Ted, or something like that. Maybe it said person A said something different. Well, you'd have to write the sentence on another line and give it rating 1. Now, in regards to looking this up in an artificial intelligence, let's go and think about what we did with the original MarkOv chain, where you chaining words together. Let's say that you gave all these sentences to the AI. They learned all those sentences and created all those tables. Now, let's say you go to say something yourself. You're talking to your chatbot and you happen to say, hello, Ted. Well, apparently in the conversation list, that was done before. So it found it in the lookup table, hello, Ted. And then what sentence responded? Well, there was 2 sentences that got responded to. There was this sentence 1 and sentence 2. But sentence 1, as a response to hello, Ted, was said more often than sentence 2. So since the rating was higher, we go ahead and use that and respond with the higher rating response. So perhaps when you said hello, Ted, the other person said, yeah, I remember Ted. And perhaps he said that 4 or 5 times, or 2 or 3 times, or whatever, in the conversation, more than anything else. Every time you said hello, Ted, that other response was more frequent. So what do you think the AI is going to say? Well, it's going to say, I remember Ted. So it's a way of adding mass conversations into an AI, and it actually statistically picking out the most frequent response to any given sentence. Of course, you can make this in an actual AI. You can make it a little bit more fuzzy. You can make things a little bit more precise. There is also, of course, you can see the value in this. Hopefully, you should be able to see the value in this. Now, of course, I'm not doing this perfectly programmatically. I'm not really like trying to code this right now. I have done it myself. I know how to do it, but this is not what this thing is about. This is more of a theory, but I'm sure you know this. Now, we have a 1-to-1 ratio here, but why can't we have a 2-to-1 ratio? Well, a 2-to-1 ratio means it has to keep track at this point. There's a certain tracking. You'll have to think about this yourself. I'm not really going to explain it, but there are ways to write a 2-to-1 ratio. There are ways to write something more precise or less precise, a 1-to-2 ratio. And of course, you have a 1-to-1 ratio, like I said, but you can have a 2-to-2 ratio. You can have a 3-to-3 ratio. It doesn't have to be just unequal, but they all work together. Yeah, so that's pretty well it on MarkOv chains. Now, the next video is going to be about, particularly about nodes, and sort of a game mechanic of using rooms as well as ratings. So it sort of has a Markov-like aspect, and we can actually create nodes and a conversational tree with this information. And we'll do that in the next video. That way I can get me some sort of rest with this video. Of course, it's been going on for about 40 minutes, so I think you need a rest too, maybe. Anyway, thanks for listening, and I hope I'm doing some good, and I was clear enough that you can actually use this information for whatever reason. Thank you. Bye.